All right, we're going to start with our first shape, which is quadrilateral Nick, and we're going to be showing that Nick is a rhombus by using the side length. So once again, remember that in order to become a rhombus, we're just going to show that all sides are congruent, okay? So if we graph our points, remember, easy mistakes to make. If it says -4, make sure you go down 4, okay? If you plot your points wrong and the shape doesn't look like a rhombus, go back and double check you plotted correctly. Over 8. Down 3. All right, and then we can just draw the lines in to connect. Remember, you just need a straight edge for this, so anything that lets you draw a straight line, whether it's a ruler or the side of a book or a folder or a bus pass or calculator or whatever. All right. So yesterday we talked about when we want to do distance, we're going to use the optional of the distance formula. This is option number 1. So x2 minus x1 squared plus y2 minus y1 squared. How many distances will we have to calculate though? All 4. Or your other option is to use Pythagorean theorem. Okay? So whatever you're comfortable with, stick with it. If we're using Pythagorean theorem, remember we're going to draw in our rise and run to make our right triangles. And if you notice that this side length of the right triangle to form CI and KN is, and I can already tell that I have an error because I went down 5 units instead of 4. 1, 2, 3, 4. And that my triangles weren't the same length. Let's try that again. So we're going down, just count the number of boxes, right? 1, 2, 3, 4, 5, 6, 7. And then over 4. And this one is over 4 and up 7. So since we have same lengths here, we only have to do Pythagorean theorem once for both of those side lengths. 4 squared is 7 squared. Together that gives us 65. And so the length of that side is equal to the square root of 65. Very good. So underneath, I'm going to put my lowercase d for distance, and then we're going to put down our kn for the first length, and put the square root of 65 for the distance, and then the little d and a subscript of ci or ic is up to you. So we're stating the distance of those two sides. And then we do it for the other two. So we have sides of 1 and 8. Very good. And when we plug in 1 squared plus 8 squared, we better get what for our final answer? 65 again. And we do get 1 plus 64, and that is 65. I said 64 and wrote 65. Okay? And so we do end up with the square root of 65. And so now we can fill in the CK, the distance of CK is square root of 65. Okay? Now that we've done the work to get the distances, we've stated what they are, we're going to make a quick statement. What can we say about this work that we've just shown? All sides are equal, so we'll say that Kn is equal to Ci, which is equal to Ck, which is equal to Ni, right? And why are those equal again? that which is the distance, right? And the distances are equal or the same. And now that we've stated that these side lengths are equal, we've done the work to justify that, we can finally end up saying Nick is a rhombus, and what property did we just demonstrate? All right. So Nick is a rhombus because all sides equal. Questions? Pretty easy. Anything crazy? Okay. All right. After you get on to the next one. Yeah. All right. Going down to number 2. Now we're going to use a little different variation. So we're just going to look at how to use, without using side lengths, what are the other options. So we're going to show that this is a rhombus by using the diagonals, okay? So something you may not do, and after this, if you don't like it, don't use it. But in order to be a rhombus using the diagonals, we actually need to show 2 things. What's special about the diagonals of a rhombus? Okay, so they got to be perpendicular, all right, is one thing. But that's not enough, because I could also draw like a kite shape, and this would also have perpendicular diagonals, but that's not a rhombus. So we also need something else. Very good. We have to show that the diagonals are going to bisect. And if they bisect and they're perpendicular, then that forces this part to become a parallelogram with perpendicular diagonals, which is a rhombus, okay? So if we're not using the distances, we have to get parallelogram first, and then an extra property to make it a rhombus. Now, if we were just using distances, by the way, I know we're not, but just a quick point. Do I have to do Pythagorean theorem for this side AT? Can I just count the number of boxes without? Yeah. So if you notice that you're doing, like in this one, you have horizontal and vertical lines, just mark it down and put the number next to it to say that it's a unit of 6 boxes, okay? So you don't have to worry about, or 5 or whatever it is. You don't have to worry about actually doing the Pythagorean theorem there, okay? All right, but we're using diagonals, so we need to get in order to do bisect, what do we really need to show? Midpoint, very good. Show that they have the same midpoint, and then for perpendicular, that's our slope. So we're going to do the midpoint first. So the first diagonal is AH and MT. So we'll start with MT because I heard that first. And we're just going to take, and remember another word for average was, sorry, I just said it. Another word for midpoint is average. So add the x's. So m, the x is 1, plus t is 3, divided by 2. And the y's is 1 plus 5 divided by 2. And so we end up getting 2, 3, right? So we get 4 divided by 2 is 2, 6 divided by 2 is 3. So I better get the same thing when I do the midpoint of AH. And so when we add them together, A is negative 2 plus 6. And then the y's is 5 plus 1. And do we end up getting 2, 3? Good, we get 4 over 2 and 6 over 2. So we do get 2, 3 again. So what does this work tell us? So if the midpoints are equal, then the diagonals bisect. Very good. So we can say MT and AH bisect each other. And then because midpoints are equal, okay? And then the last thing we need to do is the slope. Now, do you really need to draw in the right triangles here to count the slopes? No. So if you just want to count the rise and the run, but remember, we're doing the slope of what? What are we trying to figure out the slopes of? Remember, we just did number one, show they bisect. Now we have to show that the diagonals are. So what are we looking for to get perpendicular diagonals again? We know we're going to use the slopes, but how should the slopes be related? Yes, we have to show that the slopes are the opposite reciprocals. Writing on our graph here. All right? So they're negative reciprocals of one another. So we're going to do the slope of the first diagonal. Since we did MT last time, let's just stick with that. So the slope of MT. And you could just count the rise and run. How do you get from M to T? We have to go up 4 and over, careful, 2. So 4 over 2. And I would reduce this as much as possible, which makes it equal to 2. Okay? And then the slope of the other diagonal would be AH. How do we get from A to H? Well, we got to go down 4, so that's negative 4 over 1, 2, 3, 4, 5, 6, 7, 8. And remember, if this is 2, the negative reciprocal 2 is negative a half. And does this equal negative 1/2? It does. So what can I tell you about the work we just did now? That they're perpendicular. So MT is perpendicular to AH. And why are they perpendicular? Good. Slopes are negative reciprocals. And is that enough now to say that the whole thing is a rhombus? Okay. So do you see that if we're not using the 4 distances, it's a little bit more work? Okay? So it's doable, but it's just a little bit more. Go for it. Do we get full credit? Nope, because we have to say math is a rhombus. And we have to say why. Very good. So because we could just say the diagonals are perpendicular bisectors. Or perpendicular and bisecting, however you want to say it. I am not going to ask you for a specific method when you're doing this in the future. So I will just ask you to prove it's a rhombus, and your job is to go do it. So make sure you have a method down, okay? All right. What I'd like you to do in your groups is see if you can try number 3, okay? On your own. If you're working at home, go ahead and pause and try it here. Theorem. So since this line is A, B, and C, D are horizontal, you can just count the number of boxes. You don't need to use Pythagorean theorem or distance formula. Just put down 11 and you're good to go. You do need to find the distance of these two. So whether you use Pythagorean theorem or the distance formula, hopefully got the square root of 85. Okay, be careful if you square negative numbers that should come out positive. So if you got like 77 or something, it's because you did 81 minus 4 instead of plus 4. So just be careful there. And then remember, after we're done with that, we want to say what about the side lengths? Right? That 2 sets of them are equal because the distances are equal. But then we also want to take a second and just state that there's some that are not equal because they're not the same distances. Okay? If you didn't say this and you said this part, as long as you kind of explained it down here, I'll take that as well. Okay? So you should have 2 statements, one of them or one big statement combined together. One of them saying that it's a parallelogram because your opposite sides are congruent, or parallel if you use the slopes. Just make sure it's appropriate. And then 1 being the fact that it's a rhombus because not all sides are equal. By the way, you could have done the slopes for the diagonals and shown that they're not perpendicular as well. Okay? Questions? So do your thing, whatever you need here. Okay, your homework tonight is to finish up number 4. That's it. You got 9 minutes, so hopefully you should be able to get done before you leave. All right, and you're just proving it is a a rhombus in this one. Ready, set? All right, do your thing, and have a great day.